In this presentation, I will show you embedded implementation of monitoring algorithm-based precision agriculture presented by Mr. Saddik Amine. So firstly, we will start with the introduction, objective, after that precision agriculture overview, result and discussion, and finally conclusion. Monitoring of agricultural soil has become necessary for good soil quality. For this reason, several parameters have been developed to solve this problem. Among these parameters, we found, for example, NDVI, the Normalized Difference Vegetation Index, and NDWI, the Normalized Difference Water Index. The objective of this work is the evaluation of the vital parameter NDVI and NDWI and embedded implementation of the proposed algorithm. Precision agriculture or smart farming is an agricultural management system based on the application of various technology in order to improve the quality of plant and the environment. The precision agriculture generally it's based in two approaches. The first one is the satellite imagery and the second one is the robot imagery. Also, for the robot imagery, we found two types. The first one is the soil robot and the second one is the aerial robot. For our case, we are choosing the unmanned aerial vehicle. The Normalized Difference Vegetation Index is used to determine the vegetation in an agricultural area. Generally, it's based in the red band and near infrared band. For the calculation of this index, we should subtract the near from the red and near plus the red. The second one is the Normalized Difference Water Index. Is dedicated to detect the liquid particle in the vegetation. It's based in the green band and near infrared band. For the calculation of these index, we should subtract the green from the near divided from the near plus the green. Now we pass to the result and discussion. Our algorithm generally it's based on three functional blocks. The first functional block is dedicated to the acquisition of the image and separation of the band. For the second block is for the calculation of the Normalized Difference Water Index and Normalized Difference Vegetation Index. The third block is dedicated to thresholding operation and storing the different resulting image. For the embedded part, we are using the Odroid XU4 heterogeneous system based on 2 CPU and 1 GPU. As you see here, we have the result from the XU4 card. In the left, we have the Normalized Difference Water Index, and in the right, the Normalized Difference Vegetation Index. And here we have the Normalized Difference Vegetation Index, but using different thresholding. In the left, 0.5, and in the right, 0.25. And here we have the same image but using a matrix of the NDVI data. Now we pass to the implementation of our algorithm. As you see here, we have generally two propositions. The first one is the sequential implementation based only in the CPU, and the second one is the heterogeneous implementation based into the CPU and the GPU. For the first block is dedicated to band separation image to matrix. After that, this block sent the data to the second block for computing NDVI and NDWI. After that, the data collection to the thresholding operation. Here we have the difference processing time using C, C++, OpenMP and OpenCL in the XU4 and the desktop. And here we have 2010 image based on the OpenCL. Algorithms in precision agriculture are becoming more and more complex. Their implementation on embedded architecture is far from being resolved. A study of problem in an hardware-software co-design approach would eliminate the complexity and proposed solution for the unmanned aerial vehicle application. Thank you for your attention.